Today, what we're going to be talking about is chemical process diagrams. So we're going to be looking at these diagrams here and what they represent in chemical engineering. So, the vocab words. A diagram is a diagram commonly used in chemical and process engineering to indicate the flow of the plant, processing, and equipment. There's always going to be an input in the starting of the chemicals or materials that are used. This is your starting point, and then you have your output. This is the final place or where the products are being, at the end point or being produced. Then you have your raw materials, your starting materials, and where they're coming in. Now, think of this as also like, let's say, making cookies. You have your input station. Where are you starting at? Where's the materials coming from? Well, your raw materials are coming in from the fridge and from your pantries. Your input is going to be your mixers, where you're mixing everything. You're going to start that material. Your output is your stove. Okay, so finishing products, the final material or the products after the processes are done. So where's the product is. Waste, this is any chemicals or products that are not desired. This could be like your eggshells that you just throw away, or you could have slag or cutoffs from your bike manufacturing. Recycle stream. This is a product that can be reused in other processes. So you can like reuse heat or remelting something, and you cut offs from the bike and reuse them again for another process. How you heating it and how you cooling it. Again, like cooking eggs or the freezing of ice cream. There is going to be a mixer where you're mixing your chemicals, or it's the place where you're assembling the mechanism, like your bike. That would be like a mixer. The reactor is the location that chemicals and reactions occur, and the separator is where chemicals and products are separated, like removing alcohol from water, um, but a water alcohol mixture by distillation. Now, there are several different ways of showing this. There's the flow diagrams, which we have the block flow diagram, the process flow diagrams, and the piping and instrumental diagrams. There are other common diagrams, and we're going to look at 3D layouts here in just a moment. Okay, so the three levels of diagrams are your block flow, your process flow, and your piping and instrument diagrams. They increase in complexity, and conceptual understanding increases as you go down. Chemical engineers are more familiar with block flow diagrams and process flow diagrams, less so on the piping and instrumental diagrams. So let's talk about block flow diagrams. This is the overall easiest one to understand. And it shows the overall process of pictures of the chemical, how the chemicals complex. Flow of raw materials into a product may be included, and the block flow diagram is a superficial way of viewing the facility, so you can look for information. So for instance, here we go. This one, you're going to take in toluene at a specific amount, 10,000 kilograms per hour, and hydrogen at this amount into a reactor. It's going to react with this chemical with the reactor. It's going to go through the reactor. It's going to be separated, and then the gas separator will mix and it will leave at this amount. If it's a liquid, it will go down to the distillation, and the still will distill the benzene off. And if there's any toluene still left over, it gets condensed and recycled back in to be cycled back. What you're trying to do is you're taking all this toluene here and turning it into benzene, our end product, which is here. It's a very much a simple diagram. It doesn't really show you how the setup of how the actual factory is set up. The process flow diagram shows all the process engineering, the other information. This is often done as like a PDF drawing on a large piece of paper. It's usually has some topological process showing where things are going to be located, so where all the pipes and all that kind of stuff. So here's an example of that. It shows you valves and a little bit more information, where you're going to have different things. So it tells you where all these values are here. Up on the top, it tells you what they are for. So you have the same process. So we're taking toluene, taking hydrogen, and making benzene and some fuel gas. And here's our recycler. but it's a lot more complex. It shows you the check valves and all of these other input items here with different symbols and different parts, and it can tell you where these values R101, H101. That tells you information. So in fact, this is the conventional use of identifying where it is. So the XX, so if you see it, this is the general formula, XX, YZZ, A/B. XX indicates, our first two letters indicate the equipment classification. So is it a compressor, heat exchanger, fire pump, reactor, tower, storage tank, vessel, that kind of thing. The double Z's indicate the number designation for each item in the equipment class. So what is it? And then the Y designates the area in the plant, and then the AB identifies is it a parallel unit or backup unit. So you can look here, you can see this is going to tell us where at in the factories are they at, and also what they are. This is a vessel, that's a reactor, that's a heater, that's a pump, that's a vessels. So that's kind of what those are all for. Now the stream numbering and drawings, these are a little bit, when we draw streams, we always draw the streams from left to right as much as possible, and horizontal lines are dominant. So in other words, as this can happen, but not this, and never cross. Okay, you want to add arrows for change in direction or inlet for correction, so you're showing them. So you can see how a lot of these are going all the way down. There's no crossing of lines. Everything is pretty well marked off. There's arrows indicating the flow of where things are going. So you have your flow going down, over, and then up. So it's easy to follow that. The stream information, since the diagrams are so small, not much stream information can be included. So what they can do is they can add little flags, and they can actually add these little flags here, and they tell us information about how fast should it be. So here's some examples of those stream identifiers, and they just tell us how fast. So information such as temperature, pressures, vapors, total mass flows, total mole flows. You can also add in other components like density, viscosities, thermodynamic data, information that might be important to know, but not really important on such a large, this kind of a drawing, so you can add those in there. So you can have like a table of information. So you say, hey, at stream number 1, it should be these numbers. Stream number 2, it should be these numbers. And that way they can refer back to it when they are looking at their blueprints. Now the piping and instrumental diagrams are the construction person's Bible. These are going to be what the construction person looks at. This is going to give you what the plant's going to actually look like, where are the pipes going to be, and where are everything else. So it's actually going to give you a lot more information of where locations of things are going to be at. Where is the fuel gas going to be at? Where's the benzene going to be at? Where's your toluene tanks? So this is going to give us much more, a much stronger one for the construction persons. Other type of things you can actually see, other common diagrams, is like racking, pipe racks, like where are my pipes going to be located at and how are they going to be racked. Or we can look at the elevations and see how this distillation is actually elevated 3 to 5 meters from the top here. So it actually tells us where things are located at. Other common ones are piping isometric, showing piping in 3 dimensions, or vessel sketches showing key dimensions of the equipment and locations of inlet and outlet nozzles. Now 35 years ago, physical models were had to use, but now with the aid of computer software, we can now use 3D softwares, and we can actually catch errors such as piping clashing, where pipe goes into another pipe, or misaligning a piping, and equipment that isn't easily accessible, using 3D visualization. So you can actually look at this and walk around it virtually and see if any pipes are in the way. And that can really help you out and see the processes as well. So let's summarize this. There are 3 principal diagrams. and then they are used to convey increasingly specific technical information about a process. And important to adhere to is the common standard for these diagrams in order to avoid confusion. Information on equipment layout is mostly conveyed by using the 3D plant layout diagrams. So if you have any other questions, write them down and ask me in class.